Section 11.2 is all about the volume of prisms and cylinders. Let's get this into your table of contents, and then we'll get going. So, volume as opposed to surface area. Volume answers the question how much space is inside, whereas surface area is how much space is covered on the outside. So volume is always measured in cubic units, for example, cubic inches or cubic centimeters, and we understand volume as the number of unit cubes that would fill the space. So we could find the volume of this prism, or we could find the volume of this prism, or we could find the number of unit cubes in this crazy prism. And the way that we do it is we first find the area of the bottom, the base, and multiply by the height. So the volume of a prism is the area of one base multiplied by the height of the prism. And remember, the height of a prism is the distance between the bases. Let's work through an example. Here we have a right triangular prism. The bases are those two right triangles. And the area of one of the bases is 30. The distance between the bases is not what we think of as everyday height. The height of this prism is the distance between the two triangles. So even though it's laying down on its side, 7 is still the height of the prism. So the volume of this right triangular prism is 210 cubic units. Please again notice we're talking about cubic units, not square units anymore. Pretty easy to turn this volume of a prism into the volume of a cylinder. Remember, the area of one base is the area of a circle. The height of the cylinder is the distance between the two circles, and so our volume for the cylinder would be 45 pi cubic units. Here's an example for you to try. Find the volume of this square prism. Push pause if you need to. You should get 300 cubic units. Now this next slide, if you have a note card with you, you could pull it out. If you don't, we'll fill this in class. So that deals with right prisms. What about oblique prisms? So an oblique prism is one where it kind of slants off to one side. An oblique cylinder would be like the one shown there to the right. Well, it turns out that the volumes will be the same. If you think about a stack of sheets of paper, if it's straight or a little bit crooked, there's still the same amount of paper in both stacks. In other words, the same volume. You can think about it as these two stacks of crackers. They have the same number of crackers, even though one of the, cracker cylinders is a bit skewed. It's oblique. So using that idea, we can find the volume of this cylinder. We would take pi times 6 squared and multiply it by 7. 7 is the perpendicular distance between those two circular bases. How about this one? Give it a shot. Find the volume of this hemisphere. And then lastly, let's take a look at the volume of a rectangular prism with a hole drilled in it. You might be familiar with this one. We've seen this image before. But the volume, the remaining volume, is the volume of the prism minus the volume of the cylinder. So the prism is 6 by 5 by 4. The cylinder has a radius of 2 and a height of 4 as well. And so the approximate answer should be 69.7 cubic meters. Here's a problem with no picture. Well, that's no problem for us. We have a cylinder with a given volume and radius, and we want to find, given volume and height, and we want to find its radius. So we know the volume of a cylinder is pi r squared times height. We'll sub in the information we know, divide both sides by 10, then we can divide both sides by pi, and then finally to undo the square, we square root, and we get about 2 inches for a radius.